Good morning, everyone, and welcome to Module 3, Statistical Thinking for Decision Support. In this module, we are going to explore one of the most important foundations of modern analytical decision making, and that is the ability to think statistically when evaluating information, evidence, and conclusions. In today's professional environments, organizations generate enormous amounts of data every single day. Businesses track customer behavior. Governments monitor economic indicators. Healthcare systems collect patient information. And technology platforms continuously analyze user activity. However, simply having access to data does not automatically produce good decisions. The real challenge lies in understanding how to interpret that information responsibly and intelligently. Throughout this module, we will focus on the concept of statistical thinking as a framework for evaluating analytical results under conditions of uncertainty and variability. One of the biggest misconceptions people have about analytics is the belief that numbers always provide exact and unquestionable answers. In reality, data is influenced by randomness, incomplete information, human behavior, environmental conditions, measurement limitations, and constantly changing circumstances. Statistical thinking helps decision makers recognize these limitations instead of assuming that analytical outputs represent perfect certainty. As we move through this module, we will examine how statistical reasoning supports more informed decision making. Organizations often rely on reports, dashboards, forecasts, and predictive models to guide strategic and operational actions. Executives may use data to allocate budgets, forecast demand, manage staffing, evaluate risk, or assess organizational performance. Public policy leaders may use statistics to evaluate economic conditions, public health outcomes, or educational performance. In all of these situations, decision makers must determine whether the information being presented is reliable, meaningful, and appropriately interpreted. Another important theme we will discuss is the role of uncertainty in analytical interpretation. Many people are uncomfortable with uncertainty because they prefer clear and definitive answers. However, uncertainty is a natural part of real-world decision making. Markets fluctuate unexpectedly. Consumer preferences evolve over time. Human behavior is difficult to predict perfectly. Economic and social conditions continuously change. Statistical thinking does not eliminate uncertainty, but it helps individuals evaluate uncertainty more effectively and make decisions with a more realistic understanding of potential outcomes. We will also examine the concept of variability, which refers to the natural differences that exist within data. Real-world observations are rarely identical. Different customers behave differently. Different employees perform at different levels. Different geographic regions may produce different results under similar conditions. Statistical thinking helps us understand that variability is not simply noise or error. Instead, variability often contains valuable information that helps explain patterns, risks, trends, and operational realities within organizations. In addition, this module will emphasize the importance of critically evaluating analytical findings rather than accepting statistical summaries at face value. Many poor decisions occur because individuals interpret data too quickly without considering context, assumptions, or limitations. For example, averages can sometimes hide important differences within a population. Trends may appear meaningful even when they are temporary fluctuations. Correlations may be mistaken for evidence of causation. Statistical reasoning teaches us to pause, examine the evidence carefully, and evaluate whether conclusions are genuinely supported by the available information. Another major objective of this module is developing analytical discipline. Statistical thinking is not only about calculations or formulas, it's also about mindset. Effective decision makers learn to ask important questions about the quality, reliability, and interpretation of evidence before taking action. They recognize that data should support decision making, but they also understand that data must be interpreted within context and evaluated critically. By the end of this module, you should begin developing a stronger understanding of how statistical thinking supports decision support processes across many professional environments. The goal is to move beyond simply reading numbers and toward developing the ability to interpret evidence thoughtfully, recognize uncertainty realistically, and evaluate analytical conclusions responsibly. This foundation will help you become a more informed and disciplined consumer of data-driven information in both professional and organizational settings. In this section of the module, we are going to focus on the importance of statistical reasoning in interpreting analytical results. One of the most critical challenges in modern decision making is understanding that data alone does not automatically produce reliable conclusions. Organizations today have access to enormous amounts of information, including financial reports, operational metrics, customer analytics, market trends, predictive models, and performance dashboards. However, without statistical reasoning, decision makers may misinterpret analytical findings and draw conclusions that are incomplete, misleading, or entirely incorrect. Statistical reasoning helps individuals understand that real-world data is influenced by uncertainty and variability. In many situations, people expect analytical systems to provide exact answers, but real-world environments rarely function with perfect certainty. Customer preferences change unexpectedly. Markets fluctuate continuously. Human behavior is difficult to predict precisely. External events can influence outcomes in ways that are impossible to control completely. Because of this, data often reflects randomness and incomplete information rather than absolute truth. Statistical thinking allows decision makers to recognize these realities and interpret analytical results more responsibly. Another important concept in statistical reasoning is reliability. When organizations analyze data, one of the key questions should always be whether the findings are dependable enough to support decisions. For example, if a company observes an increase in sales during a specific month, statistical reasoning encourages decision makers to ask whether the increase reflects a meaningful trend or simply temporary variation. Without this type of analytical discipline, organizations may react too quickly to patterns that are not actually significant over time. Statistical reasoning also helps decision makers avoid overconfidence in analytical outputs. One of the dangers of modern analytics is that numerical results often appear authoritative simply because they are presented quantitatively. People tend to trust charts, percentages, averages, and predictive models because they seem scientific and objective. However, numbers can be misunderstood when the underlying assumptions, the limitations, or uncertainties are ignored. Statistical thinking reminds us that analytical findings must always be interpreted within context rather than accepted blindly. A major aspect of this process involves understanding variability in data. Variability refers to the fact that observations are rarely identical across individuals, groups, locations, or time periods. In business environments, different customers may respond differently to the same product. Different departments may perform differently under similar conditions. Different regions may experience different economic outcomes even when operating under comparable circumstances. Statistical reasoning helps individuals recognize that variation is a natural part of data rather than simply an error that should be ignored. In addition to variability, statistical reasoning addresses incomplete information. In many decision-making situations, organizations do not have access to every possible piece of data. Analysts often work with samples rather than entire populations. Surveys may contain response bias. Historical data may not perfectly predict future conditions. Measurements may contain errors or limitations. Because of these realities, analytical conclusions must be interpreted carefully and with an understanding of their limitations. Another important benefit of statistical reasoning is that it supports more informed and balanced decision making. Instead of assuming that data provides certain answers, decision makers learn to evaluate probabilities, assess confidence levels, and consider alternative explanations for observed outcomes. This approach leads to more thoughtful decisions because it recognizes both the strengths and limitations of analytical evidence. Consider the difference between simply reading a report and interpreting it statistically. A report might indicate that customer satisfaction increased by 5% over the previous quarter. A superficial interpretation may immediately conclude that organizational performance improved significantly. Statistical reasoning, however, encourages deeper analysis. Was the sample size large enough? Were there changes in how satisfaction was measured? Could external conditions have influenced responses? Is the increase consistent across all customer groups or concentrated within a specific segment? These questions help decision makers avoid simplistic interpretations and evaluate evidence more critically. In this section, we are going to examine how statistical findings are commonly interpreted in business and policy reports. Modern organizations rely heavily on reports to summarize information and support decision-making processes. Businesses use analytical reports to evaluate sales performance, customer behavior, operational efficiency, financial outcomes, market conditions, and strategic performance indicators. Government agencies and policy organizations use statistical reports to assess economic trends, public health conditions, educational outcomes, employment rates, crime statistics, and demographic changes. Because these reports influence important decisions, the ability to interpret statistical findings correctly becomes extremely important. One of the most common ways organizations present information is through statistical summaries, such as averages, percentages, trends, comparisons, and projections. These summaries are designed to simplify large amounts of information so decision makers can identify patterns more quickly. However, statistical summaries can sometimes create misleading impressions when they are interpreted without considering the broader context surrounding the data. Statistical thinking helps decision makers evaluate not only what the report says, but also how the information is being presented, and whether important contextual details may be missing. Consider the use of averages in organizational reporting. Averages are useful because they provide a simplified representation of a data set, but they can also hide important differences within the data itself. For example, a company may report that employee productivity increased across the organization. While the average performance may appear positive, the improvement could be concentrated within only one department, while other departments experience declines. Without examining variability and distribution, decision makers may incorrectly assume that all areas of the organization improved equally. Trends are another common feature in business and policy reports. Reports often present upward or downward patterns to suggest improvement, decline, or future expectations. However, statistical reasoning reminds us that trends must be interpreted carefully. Short-term fluctuations may appear meaningful even though they represent temporary variation rather than long-term change. Decision makers who react too quickly to limited data may implement unnecessary or ineffective actions based on patterns that are not truly stable over time. Comparisons between groups also require careful interpretation. Reports frequently compare regions, departments, customer segments, demographic groups, or time periods. These comparisons can be valuable, but they may also oversimplify complex situations. For example, if one region outperforms another in sales growth, statistical reasoning encourages decision makers to ask additional questions. Were economic conditions similar in both regions? Did both locations operate with the same resources? Were there differences in customer demographics or market competition? Context matters because statistical findings do not exist independently from the environments in which the data was collected. Another important issue involves uncertainty within reported findings. Many reports present numerical results in ways that appear highly precise, which can create false confidence in the conclusions being presented. In reality, analytical findings often contain uncertainty due to sampling limitations, measurement error, incomplete information, or unpredictable external influences. Statistical reasoning helps decision makers recognize that reported figures are estimates and interpretations rather than guaranteed truths. Business and policy reports can also become misleading when supporting context is ignored intentionally or unintentionally. For example, a report may highlight a positive increase in performance while failing to mention important external factors that influence the outcome. A decline in operational costs may appear beneficial at first glance, but deeper analysis may reveal that service quality also decreased significantly. Statistical thinking encourages individuals to evaluate the completeness of the information being presented, rather than focusing only on favorable summaries or headline numbers. Another critical aspect of interpreting reports involves recognizing the difference between correlation and causation. Reports sometimes present relationships between variables that appear connected statistically. However, statistical association alone does not prove that one factor directly caused the other. Decision makers who misunderstand this distinction may implement policies or strategies based on incorrect assumptions about cause and effect relationships. Proper interpretation of statistical findings ultimately improves the quality of organizational decisions. In this section of the module, we're going to analyze how uncertainty and variability influence analytical conclusions. One of the most important realities in statistical thinking is recognizing that real-world data rarely produces perfectly certain outcomes. In many professional environments, decision makers often want clear answers, precise forecasts, and predictable results. However, analytical conclusions are almost always influenced by uncertainty, randomness, incomplete information, and natural variation within the data itself. Understanding these concepts is essential because organizations that ignore uncertainty and variability often make inaccurate assumptions and poor decisions. Let us begin with the concept of variability. Variability refers to the fact that observations and outcomes naturally differ across individuals, groups, locations, or time periods. In business environments, customer behavior varies from one consumer to another. Employee performance differs across departments. Sales results fluctuate across regions and seasons. Financial markets rise and fall continuously. Even when organizations apply the same strategies under similar conditions, outcomes may still differ because real-world systems are influenced by many interacting factors. Statistical thinking helps decision makers recognize that variability is not necessarily a problem or an error. Instead, variability is a normal characteristic of real-world data. In fact, variability often provides valuable information about patterns, risks, operational differences, and environmental influences. For example, if customer satisfaction scores vary significantly across locations, that variability may indicate differences in management practices, service quality, staffing, or customer demographics. Rather than ignoring variation, statistical reasoning encourages organizations to analyze and understand its underlying causes. Another critical concept is uncertainty. Uncertainty exists because organizations rarely possess complete knowledge about future conditions or all factors influencing outcomes. Even the most sophisticated analytical models cannot predict future events with perfect accuracy. Consumer preferences may change unexpectedly. Economic conditions may shift rapidly. Competitors may introduce new products. Government policies may influence markets in unpredictable ways. Because of these realities, analytical conclusions should always be interpreted with an understanding that uncertainty is unavoidable. One of the major dangers in decision making occurs when individuals assume that analytical results represent absolute certainty. For example, a predictive model may forecast increased product demand for the next quarter. While the model may provide useful insights, statistical thinking reminds us that the prediction is based on assumptions, historical patterns, and probabilities rather than guaranteed outcomes. External events or changing conditions may produce results very different from those expected originally. Incomplete information also contributes significantly to uncertainty in analytical interpretation. In many situations, organizations make decisions based on samples rather than complete populations. Surveys may contain limited participation. Operational data may be missing observations. Historical information may not fully represent future conditions. Measurement processes may introduce errors or inconsistencies. Statistical reasoning helps decision makers evaluate how these limitations influence the strength and reliability of analytical conclusions. Ignoring variability and uncertainty can lead organizations to develop unrealistic confidence in their conclusions. This often results in poor strategic decisions because leaders assume analytical findings are more precise or dependable than they actually are. For example, a company may expand aggressively into a new market based on limited short-term data while failing to recognize that market conditions are highly volatile. If uncertainty and variability are ignored, organizations may underestimate risks and overestimate the reliability of their forecasts. Another important aspect of statistical thinking involves evaluating the strength of evidence rather than treating all conclusions equally. Some analytical findings are supported by strong and consistent evidence across multiple observations, while other findings may be based on weak or unstable patterns. Decision makers must learn to distinguish between reliable trends and temporary fluctuations caused by randomness. This ability helps organizations avoid reacting impulsively to short-term changes that may not represent meaningful long-term developments. Ultimately, understanding uncertainty and variability allows decision makers to interpret analytical results more realistically and responsibly. In this final section of the module, we are going to evaluate potential misinterpretations of statistical evidence within decision-making contexts. One of the greatest risks in modern analytical environments is not simply the absence of data, but the incorrect interpretation of data that already exists. Organizations today rely heavily on statistical evidence to support decisions involving business strategy, operations, finance, healthcare, education, technology, and public policy. However, statistical findings can easily be misunderstood when decision makers fail to evaluate evidence critically or ignore important limitations within the data itself. One common source of misinterpretation occurs when variability is ignored. Real-world data naturally contains variation because individuals, systems, environments, and conditions differ continuously. When decision makers focus only on averages or summary statistics, they may overlook important differences hidden within the data. For example, an organization may observe an overall increase in productivity and conclude that performance improved uniformly across all departments. In reality, the increase may be driven entirely by one high-performing group, while several other areas experience declines. Ignoring variability can therefore create misleading conclusions about organizational performance. Another major issue involves drawing conclusions from incomplete information. In many professional environments, decisions must be made before all information is available. Surveys may contain limited participation. Samples may not represent the full population accurately. Historical data may fail to capture changing future conditions. External factors influencing outcomes may not be measured directly. Statistical reasoning helps decision makers recognize that incomplete information reduces certainty and increases the possibility of error in analytical interpretation. Misinterpretation can also occur when statistical summaries are accepted without critical evaluation. Numerical findings often appear persuasive because they are presented quantitatively. Charts, percentages, rankings, and trend lines may create the impression of objectivity and precision. However, statistical evidence must always be examined within context. For example, a report showing increased sales revenue may initially appear positive, but deeper analysis could reveal that operating costs increased even faster, reducing overall profitability. Without critical evaluation, decision makers may focus on favorable statistics while overlooking other important dimensions of the analysis. Another important problem involves confusing correlation with causation. Statistical evidence may reveal that two variables move together or appear associated with one another, but this does not necessarily prove that one variable directly caused the other. Decision makers sometimes assume causal relationships too quickly because the data appears convincing. For instance, an organization may observe that employee training participation increased during the same period that productivity improved. While the two factors may be related, statistical reasoning requires further analysis before concluding that training alone caused the productivity increase. Other variables may also have contributed to the outcome. Confirmation bias also contributes significantly to statistical misinterpretation. Decision makers sometimes focus selectively on evidence that supports their existing beliefs while ignoring contradictory information. This can lead organizations to overstate the significance of favorable results and underestimate risks or limitations. Statistical thinking encourages individuals to evaluate evidence objectively, rather than interpreting data only in ways that reinforce pre-existing assumptions. Another source of error occurs when decision makers place excessive confidence in small data sets or short-term trends. Temporary fluctuations may appear meaningful even though they do not represent stable long-term patterns. For example, a business may experience a sudden increase in customer demand during one quarter and assume the trend will continue indefinitely. If decisions are made without considering uncertainty and long-term variability, organizations may overreact to temporary conditions and implement ineffective strategies. Critical evaluation of statistical claims is therefore essential for responsible decision-making. Effective decision makers do not simply accept analytical findings at face value. Instead, they ask important questions about data quality, sample size, variability, assumptions, context, methodology, and reliability. They recognize that statistical evidence should support decision making, but they also understand that all analytical conclusions contain limitations and uncertainty.